This is question 7 of the SACE Stage 2 Physics course companion from section 1.2 Forces and Momentum. So a ball of mass 2.5 kilograms moving at 12 meters per second strikes the ground at 30 degrees above horizontal and bounces back at 30 degrees above horizontal without a change in speed. And we are first working out the magnitude of the change in velocity of the ball. So what we need to do is do a vector subtraction. So first draw a flat surface. The initial velocity of the ball comes in roughly like this. This is not to scale, so this will be 30 degrees. The final velocity is the same, but out like that. And so we're trying to work out the change in velocity, which will be the final take the initial velocity, which sometimes we can think of as final plus negative initial. This helps us work out what the direction is going to be. So here we'll redraw this. So we have final coming out here, initials coming in at 30 degrees like this. So if we do the negative initial, that'll be the same thing but going in the other direction. And the way we do the vector addition in this case, so we're going VF plus negative VI, so put one on top of the other, and then we can see that this is 30, that'll be 30, that'll be 30, and our delta V will be like this. We get 60 degrees here, 60 degrees here, therefore we have an equilateral triangle. So for all these vector additions and subtractions, we should be mainly seeing right-angled triangles and equilateral triangles. This happily works out to be an equilateral triangle. Now, since we want the magnitude of the change in velocity, the initial velocity is 12, the final velocity is 12, and since it's an equilateral triangle, the magnitude of the change in velocity will also be 12. So since the magnitude of the initial velocity equals the magnitude of the final velocity, which equals the magnitude of delta V, we have delta V is 12 meters per second. So now we have to work out the change in momentum of the ball, the magnitude of the change in momentum. So we have delta P will be M delta V. The mass of the ball is 2.5. So we're working out the actual momentum and put some vectors on here. So 2.5 multiplied by 12 meters per second. We put into our calculators, we should get 30 newtons directed vertically upwards. Since momentum is a vector quantity, we need to specify the direction. And finally, we want to work out the force that the ground exerts on the ball if it's in contact for 5 milliseconds. So we are using the relationship F equals delta P over delta T. We've just calculated the change in momentum. The change in time will be 5 times 10 to the minus 3 seconds, which if we substitute into our calculator, we should get 6,000 newtons. It's better to write that as 6.0 times 10 to the power of 3 newtons. Force is a vector quantity, so this is also going to be vertically upwards. And there we have it. So yeah, like all the other questions that we do with the vector addition or subtraction, we get a nice equilateral triangle here. And then the equilateral triangle ones are obviously the easiest ones because each of the sides will be the same and all these values are very simple to calculate. And there we have it.